Hello, hi everyone. Welcome to the Student the Brand. This is your Siva sir. So today we are going to discuss about electricity chapter. So electricity chapter. So that is continuing only. Constantly we are working on electricity chapter. I said in the previous classes what is the importance of electricity chapter, how to do it, how to we have to look into that, and how to practice. What are the points we need to work out on it? So everything discussed. Now we are completely in the practice session. So I hope yesterday I completed about yeah, Ohm's law. So resistors, Ohm's law about is nothing but the potential difference across a metallic conductor is directly proportional to current flowing through it. The potential difference across a metallic conductor is directly proportional to current flowing through it. So I explained that is Ohm's law. So in the yesterday class. So today class, so we'll discuss resistors are connected in series combination and resistors are connected in parallel combination. Resistors are connected in series combination and resistors are connected in parallel combination. So we will discuss that point. Okay, so we'll work out on it. Resistors are connected in series, resistors are connected in parallel. So based on this one, problems will come related to resistors are in series, resistors are in parallel. Resistors are connected, resistors are connected in series combination. Resistors are connected in series combination, in combination series combination. Resistors are connected in series combination, we will discuss. So I will explain how to do it. Normally, so identifying the resistor. So here you can see, I'm considering this is the one resistor, so another one, and the next one. So three resistors are connected in series combination. So I'm considering here, these three resistors are connected in series combination. Okay. So now I am considering here. So ammeter I am taking here. So that is battery here. Battery. So switch. Okay. So I'm considering like this. Like this I am taking. So here R1. This is R1, R2 and R3. So three resistors. Across three resistors I connected voltmeters across three resistors. I'm connecting voltmeter. So V1 and V2 and V3 across R1 R2 R3 across R1 R2 R3. So this closed switch and current is passing through it. Here we have to take. Okay, so these are the things we need to consider. Here positive terminal, negative terminal. Here I am considering positive and a negative at the end. So current is passing in this direction. Okay, so I am considering here from Ohm's law, V equal to IR. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR. So V is directly proportional to current. When the current is passing through the metallic conductor, the potential difference across it. So the potential difference across metallic conductor is directly proportional to current flowing through it. So the potential difference across the metallic conductor, so is directly proportional to current flowing through it. V is directly proportional to V equal to IR. V equal to IR I am considering. So now I'm considering V equal to IR, V equal to IR. Okay, so V equal to IR I'm considering. Now we can see V equal to IR. So from this, entire the current, entire the circuit current is same. Entire the circuit current is same. Entire the circuit current is same. Okay, so same current I am taking. Then, so we can take Vs equal to V1 plus V2 plus V3. So Vs equal to V1 plus V2 plus V3. So from this I am considering IRs equal to IR1 plus IR2 plus IR3 I'm considering here. So IRS equal to IR1 plus IR2 plus IR3. Yes, I will give. Now I'm explaining this one, right? After this completion of this one, definitely. So what is your name? I'll explain Ohm's law. So can you tell your name? Then I can call your name. Okay, so come to the point. So those who are new to the channel, please do like, share and subscribe to the channel. Then you can get the notifications whenever I'm starting, whenever I'm uploading the videos. Okay, so even community post also MCQs are there, so you can get it. Now I'm explaining. So IRS equal to IR1 plus IR2 plus IR3. So here you can see I common I am taking IRS equal to I, if you are taking common, R1 plus R2 plus R3. So R1 plus R2 plus R3. So II get cancelled. So II get cancelled. I'm taking. So II get cancelled. Then we will get RS equal to R1 plus R2 plus R3. So RS equal to R1 plus R2 plus R3. So this is about ohms. This is about resistors are connected in series combination. Resistors Shonish. So okay, definitely I'll give explanation. So now resistors are connected to parallel combination, that I will complete. Then we will go to the Ohm's law. So I'll explain Ohm's law. Okay, so stay in the channel, subscribe my channel, like, share and subscribe. Then you will get the notifications. Definitely I'll explain. So here, why we are taking V1 plus V2 plus V3 means, so here current, entire the circuit current is same. Entire the circuit current is same. Then second point is, so from Ohm's law you can take V equal to IR. So anyway we need to find out effective resistance. We are going to find out effective resistance. Effective resistance is different. So the resistance is definitely potential difference will be there, right? So if I take R1, R2, R3 equal to R, like something, if I take R1 equal to R2 equal to R3 equal to 3, if you take 2, if you take, if some number, if you take V1 equal to V2 equal to V3 equal to V. But so here I am taking different resistors. So the different resistance. That is the reason I mentioned R1, R2, R3, R4. Sorry, R1, R2, R3 like that. R1, R2, R3 like that I mentioned. So if I take in the same thing, then it will be good, right? So then it will be good. That's why. So I'm not mentioning that one. I didn't mention R1, R2, R3 like that. So I mentioned in that way. So different resistors. So that's the reason Vs equal to overall potential difference in series combination equal to Vs equal to V1 plus V2 plus V3 plus like that. So like that we consider V1 equal to V1 plus Vs equal to V1 plus V2 plus V3. So overall series combination potential difference. Like so here we have to we are getting. So the potential difference here. So like that, whatever the potential difference we are getting, right? So here how much we'll get? So here 1, 2, 3. If you add all these things, then we will get finally here. Okay, whatever we are getting here. So by adding V1, V2, V3 only we will get here. That is the reason Vs equal to V1 plus V2 plus V3. That is the reason I am considering Vs equal to V1 plus V2 plus V3. And here From that, so we know Rs equal to R1 plus R2 plus R3. If n number of resistors are connected in thank you, Shivani. So I took your advice. So I changed. I worked out it. Thank you. Thank you for your suggestion. So I am considering Rs equal to R1 plus R2 plus R3. Rs equal R1. So I am considering here as Rs equal to R1 plus R2 plus R3. Then if n number of resistors are connected, Rs equal to Nr. Rs equal to Nr. So Rs equal to Nr. So like that we can take. Like that we can consider. Okay. So make a note of it. Make a note of it. So I'll come back. So just to 5 minutes. 5 minutes. 5 minutes. So make a note of it. I will come. So again I will now time is 9:16 again will start. Will start. Okay. So note down 9:16 p.m. So we'll start again. Okay, sir. I understood. Thank you, sir. By the way, I am Shonish. Hi, Shonish. How are you? So welcome to the class. Right. Shall we start? I hope it is clear to you. So that is about the. So resistors are connected in a series combination. So now I will work out on resistors are connected in parallel combination. So Savanish, I will explain your Ohm's law. So do you have any doubts, students? So if you have any doubts, you can ask me. So I'll explain. Otherwise, I'll go to the further till now. Whatever you have doubts, whatever I explained till now. So if you have any doubts in that, you can ask me. Otherwise, I will explain next topic. That is resistors are connected in parallel combination. So if you have any doubts, let me know. Okay, done. So now Ohm's law I will explain. So one student asked. So Ohm's law if you are taking Ohm's law is nothing but if you are taking the resistor here, so I'm connecting a voltmeter across here. Voltmeter I'm connecting. So here across a resistor is there. So here is ammeter. Ammeter I'm taking. So from this one I'm taking the battery. So battery. So next one here. Switch here. Switch. So from here current is flowing from this. So positive terminal, negative terminal, positive terminal, negative terminal. This is a resistor. So X and Y. X and Y. So here you can observe. Here you can observe. I am taking here. So we are connecting one by one. We are connecting one by one like this. So current is flowing like this. Across this wire also current is flowing. So definition. So definition, if you are taking the potential difference. So the potential difference across a metallic conductor, across the ends of the metallic conductor, the potential difference of the ends of the across ends of the metallic conductor, or the potential difference between 2 points of the metallic conductor, so between ends of the metallic conductor, is directly proportional to current flowing through it. Is directly proportional to current flowing through it. Simple definition. The potential difference across this metallic conductor is directly proportional to current flowing through it. Is directly proportional to. Hi Tanishka, how are you? Welcome to the class. So you are joining, nice. So constantly you are attending. So regularly you are attending. Try to attend the class. Ask doubts. Definitely, okay na? So we'll work out on the concept. So I am considering here current is passing through it. So V is directly proportional to I. V is directly proportional to I. The potential difference across the metallic conductor is directly proportional to current flowing through it. Whatever the current is flowing through it is directly proportional to I. So V equal to IR. V equal to IR. So Ohm's law gives the definition of resistance. So this is the resistance. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. So that is definition. So from here I will give one triangle. That is nothing but if you are taking V here and I into R. So here we can take I equal to V by R. So I equal to V by R and R equal to V by I. R equal to V by I. V equal to IR. So V equal to IR. So if you remember this triangle, so top portion is V, lower portion is. So please summarize this chapter. Yes, ma, sure, definitely. Because I'm working on it. So it is a lengthy chapter. Lengthy chapter in the sense we need to work out more problems, concept. So definitely after completion of each and every concept, I will summarize. Yeah, sure. Definitely I'll summarize all the points. So nearly it will take 2 hours. So in my point of view, 2 hours. It will take 2 hours electricity chapter, everything. If I explain each and every point and including problems, 2 hours. So if I want to summarize only concept, it will take 40 minutes. Summarizing only concept, it will take 40 minutes. So overall concept including some examples of problems, it will take 2 hours. Definitely I will do it. Definitely will work out on it. Okay, now I am explaining about Ohm's law. So I'll concentrate and note it. Next one next time I will explain about summarizing complete chapter. Now here see. So this is about Ohm's law. So the potential difference across a metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. So from this triangle you can remember V equal to IR. V equal to IR. V equal to IR. So I equal to V by R. R equal to V by I. So like that we can take. Next one, materials required. So what are the materials required? Give me more hard questions based on the resistors, please. So let me complete one question now, then I'll go to the next one. Materials required. What are the materials required first? So here, first one we are considering. First one, 4 cells of 1.5 volts each. So here I am taking what are the, how many cells here? 1.5 volts, 1.5. So like that 4 I am taking. Definitely I will give. So whatever you ask, definitely I will work out on it. So one by one, topic by topic I will come. Okay. Then 4 cells, 1.5 volts each. And next one, resistor. Resistor is nichrome wire here. Resistor is a nichrome wire. Nichrome wire. I'm concerned. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichromire is an alloy of nickel, chromium, manganese and iron metals. It is an alloy. It is an alloy. Okay, so it is an alloy. And coming to the third one, so switch I am taking, switch. So metals required. What are the metals required? Next one, fourth one, ammeter. So ammeter I'm considering. Next one, voltmeter. So fifth one is voltmeter. Voltmeter I'm considering like this. So instead of writing, just I took the symbols. And the next one we can go for connect. So sixth one is about connecting wire. So these are the materials required. So definition is the potential difference across the metallic wire. How are you, sir? Hey, hi, Daniel. Welcome to the class. So here we can take the potential difference across the metallic conductor is directly proportional to current flowing through at a constant temperature. Here temperature must be constant. Even physical conditions also constant. So temperature constant we are considering. Temperature at a constant temperature, the potential difference across the metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. It is simple only. So students are asking. So that's why I'm explaining. Yes. So let me concentrate. Let me work out on it. Still you are waiting for ICSE. Yeah, of course. See, even I'm working on it. So CBSE, it's going on. ICSE, I will try. As I said, ICSE, if students asking two or more, then like see, you are asking continuously. I already said. So I'm uploading the videos. In playlist. So my videos are there. I'll try to do it. So like a live class, I will plan. Okay, done. Thank you for understanding. So these are the materials. Required. What are the materials so we took next one, procedure. We are going for a procedure. So procedure. Okay. So like this. So I'm going to the procedure. So procedure is, first we have to connect one cell. Procedure. First we have to connect one cell. Okay. So I'm taking here. First you have to connect one cell and note down the reading of ammeter and voltmeter. Next, so next one we can take two cells, connect two cells and measure the reading of ammeter and voltmeter. So and connect three cells. First step is connect one cell, and second one connect two cells, and next one connect three cells, and four cells. Repeat the process for measuring taking the reading of ammeter and voltmeter, and mention in the tabular form. So mention in the tabular form. The tabular form is like this. The tabular form here, if you are considering like this. So I am taking here. So serial number of resistors, ammeter, voltmeter, V by I value. So 1, 2, 3, 4. So serial number of cells, and ammeter reading, voltmeter reading, V by I form. So normally V equal to IR, right? V equal to IR. So R equal to V by I. R equal to V by I. So V equal to IR, R equal to V by I. So V by I, that is nothing but resistance. So resistance. So now 1, 2, 3, 4. So four resistors and serial number 4, and the number of cells also 4 cells. And we have to measure the reading of ammeter and voltmeter. So each and every time one cell take the reading of ammeter and voltmeter, mention in the tabular form, and find out the current. Find out the resistance. Next two cells. So note down the reading of ammeter and voltmeter and resistance. So next one, repeat the process for 3 and 4 and note down. Then you will get the then you can understand the this values. So by drawing this graph between potential difference and current, potential difference and current. So if you are drawing the graph between potential difference and current, so the graph is straight line. The graph is straight line. The graph is straight line. Okay. So the graph is straight line. The graph is straight line because so here you can see it obey the conductors which obey Ohm's law. Those are called ohmic conductors. Ohmic conductors. Ohmic conductors. Ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. So you can see the graph is straight line. The graph is straight line. The graph is straight line. So for ohmic conductors, the graph is straight line. For non-ohmic conductors, the substances which does not obey Ohm's law, those are called non-ohmic conductors. The non-ohmic conductor graph is curved. So the graph is curved. You can see the graph is curved. The graph is curved. So normally if you are taking for ohmic conductors, the graph is straight line, linear. For non-ohmic conductors, the graph is curved. So the graph is curved. So this is about Ohm's law. Procedure is first you have to take one cell and note down the reading of ammeter and voltmeter. So two cells connect. That is the reason each and every time you have to connect the cells. And one more question. So what is the reason behind that? The graph is linear. The graph is linear. So the graph is starting from origin, right? The graph is starting from the origin. So why it is starting from the origin? What is the reason? Because first we are connecting the one cell. So we are connecting one cell. Then we are noting down the reading of ammeter and voltmeter. Ammeter and voltmeter we are noting. Okay, we are taking. So that's why. So the initial values are starting from 0. That is the reason the graph is linear. The graph is linear. VI graph for ohmic conductors. For ohmic conductors only the graph is straight line. For non-ohmic conductors the graph is not straight line. It is curved. It is curved. Okay. So this is about so that is about we can take ohmic conductors and non-ohmic conductors. So that's enough. That is a process. Next one we are going for this. Sonish, do you understand? So I explained for you only. You asked this one, right? So this is the Ohm's law. Sonish. So fine. So I hope if you are there, you are listening. Just let me know. So whether you understood or not. So otherwise, I'll go to the next one. Resistors are connected in a parallel combination. So I'll explain resistors are connected in parallel combination. Resistors are connected in parallel combination. Okay, done. Thank you. So next one, resistors are connected in parallel combination. Resistors are connected in connected in parallel combination. Are connected in parallel combination. Parallel combination. Resistors are connected in parallel combination. So resistors are connected in parallel combination. So it will be. So thank you. Now I'm going to the resistor. So if you are taking, so this is one resistor like this. So another one. So next one. So this is ammeter. Next one, battery. So this is R1, R2, R3. So I'm considering potential difference here. Okay. So current is passing like this, positive, negative. So it is positive, negative. So here you can observe what are the current is flowing from battery to the resistors. So here I'm considering R1, R2, R3. So those who are there in the live class, so do like, share and subscribe. So by that remaining students also they can join. So this video will suggest to another students also. Present sir, Aish, present. So do like, share and subscribe. So it's request, do like, share and subscribe, and share to your friends, share on the what are the possible ways. So share. Remaining students also they can join, they can come and join, they can attend the class, they can learn the concept. So if you are attending this channel, if you are attending the class, definitely with my possibility, definitely you'll get good content. So you'll get all your doubts will be clarified. Okay, so in physics, so you'll get good content, so good knowledge. Definitely you'll get you'll be improving in physics day by day. You are improving in physics, so definitely you'll get it. For that you have to attend the class, listen the class, ask the doubts, practice once. After the class also you can practice once. Definitely you'll get it. So the point is you must work out along with me. Okay, so thank you so much, and inform your friends also, those who want to join. So let them know, let them inform. So let them come and join to the class, attend the class. So if they have any doubts, ask them. No, they can ask. Definitely I'll clarify. I will if you ask any doubt, definitely I will clarify your doubt. Okay, so in the live class itself. So next one, so I'm going to the next one, R1, R1, R2, R1, R2 and R3, R1, R2, R3. Okay, so current is passing through this one. Current is passing from positive terminal to negative terminal. Now we can see from Ohm's law V equal to IR. From Ohm's law V equal to IR, I'm considering I equal to V by R. 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 So here we can take IP equal to I1 plus I2 plus I3. I1 equal to I1, IP equal to overall current in the parallel combination. So overall current, how much our current is flowing from the battery. So whatever the current is flowing from here. So that is a combination of I1 plus I2 plus I3. So here current is dividing, right? Here current is dividing. So that we are adding. That's enough. So I1 plus I2 plus I3, that is nothing but IP. IP equal to I1 plus I2 plus I3. So now we are considering IR. So V by RP. So from here you can see, from this, so we can consider V equal to I equal to V by R. I equal to V by R. Here I equal to V by R. I equal to V by R. So this is the formula. So from that we can take here. So V by RP equal to V by R equal to V by R1 plus V by R2 plus V by R3. So V by R3. So you must work out along with me. So note down the points whatever I'm writing on the board. So make sure that. So V by RP equal to, so V we can take common. V by RP equal to, so V I'm considering common. So R1 plus R2 plus R3. So 1 by R3. 1 by R3. So VB get cancelled. VB get cancelled. So then the formula is 1 by RP equal to 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R1 equal to 1 by R2 plus 1 by R3. 1 by R3. Clear? So now you can see if n number of resistors, n number of resistors are connected in parallel combination. If n number of resistors are connected in parallel combination, then the formula is, so 1 by Rp equal to n by R. So then Rp equal to R by n. R by n. So this is the formula. Just note down the chapter. Whatever I explained till now, note down once. So next we will go for actually one more topic is there. Resistors are factor depends on resistance. I will explain that also. Factor depends on resistance. Make a note of it. Practice one time. So practice one time. Practice once. Okay, so I'll start. 9:40 I'll start. I'll start again at 9:40. So one time you practice, you have to practice once. Simply attending the class is not enough. You must practice one time. So practice one time, practice once. I will start again at 9:40 p.m. Okay, so next I'll explain resistors are connected in parallel combination. Okay, so next one. So here you can see the next one I'm working on it. Resistors are factor depends on resistance. Factor depends on resistance. I'll explain now. Factor depends on resistance. Factors depends on resistance. Factors depends on resistance. So resistance depends on length of the conductor. Resistance depends on length of the conductor. R is directly proportional to L. So normally, see, this type of questions will come related to this one. Shonish, you asked about resistor, right? So these questions will come. Resistor and resistivity, very very important. Resistor and resistivity, you can see. R is directly proportional to it. If you are taking long length, so resistance will be more. If you are taking short length, resistance will be less. So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Resistance is inversely proportional to area of the conductor. Area of the conductor. So R is directly proportional to L by A. So R equal to, from this R equal to rho into L by A. So this formula is very very important. So related to this one, problems will come. So either 2 mark, 1 mark and 3 marks also will come from this. Okay, so either 1 mark, 2 mark, so 3 marks also. Problems will come. Problems are very very important from the chapter, especially electricity. So that's why I'm considering now. Okay, so here you can observe R equal to rho into L by A. R equal to rho into L by A. So R is directly proportional to L. R is inversely proportional to area. R is directly proportional to L by A. So R equal to rho into L by A. From this, rho equal to RA by L. So from this, rho equal to RA by L. So what is R? R is a resistance. R is a resistance. R is a resistance. So I'm considering the resistance. So rho is the resistivity. Rho is the resistivity. R is the resistance. Rho is the resistivity. 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 R is the resistance. Rho is the resistivity. So here I'm considering now resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. So R is directly proportional to L by A. So rho is the resistivity. Rho is the resistivity. So rho equal to, so from this formula, rho equal to RA by, so RA by L. So rho equal to RA by L. RA by L. So resistivity is equal to, here definitions if you are saying, so resistance is the phenomena of opposing the electric current in the circuit. So resistance is nothing but the phenomena of opposing the electric current in the circuit. Resistivity is nothing but resistance of the conductor per unit length and unit cross sectional area. Resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. So that is about resistivity. So here is the resistance. Resistance is the phenomena of opposing the electric current. So phenomena of opposing the electric current. Resistivity is nothing but resistance of the conductor per unit length and unit cross sectional area. Okay, so we can take now rho equal to R into, so A by L. So like R by L. R by L. R by L into A. So resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. So that is like that we can define by seeing the formula only. We can understand the definition of the resistivity. So resistance directly we know. So the phenomena of opposing the electric current. Okay. So now we will go to, I will explain about SI unit of resistivity. So SI unit of resistivity is, SI unit of resistance is ohm. SI unit of length is meter. SI unit of area is meter square. SI unit of resistance is ohm. SI unit of length is meter. SI unit of area is meter square. So here meter get cancelled. So here meter get cancelled. Then you will get a ohm meter. So resistivity is equal to ohm meter. Resistivity is equal to ohm meter. So I am requesting all, please support my channel. So let everyone knows, join to the class. Definitely I will give my best to teach physics. Definitely you will get good content. So from my end, this is a promise, get good content. So definitely you will improve in physics. So your doubts will be clarified. So definitely from my end I am telling, So you will improve your physics. Okay. So please support my channel. Please do like, share, and subscribe, and inform to the everyone. Star best, Shiva sir is best. Okay, thank you so much. Please support and spread a word. Spread a word. Share this channel to everyone. So ask them to support. That is what I want. That's enough. So nothing else. So you can ask any doubt. Definitely from my end, it's a promise. You will improve your physics. So you can ask any doubts related to physics. I'll clarify. I will explain. Okay. So if possible, I in the live class. If not, next time also I'll try to take. Definitely your doubt will be clarified. Ask doubts. Again, I'm saying ask your doubts. Okay. So pose your doubts or comment in the section. Okay. So you can do comment. Definitely I will respond to the comment. So related to physics questions. So okay. So thank you so much. Please support my channel. That is what I am asking you all. Right. So factor depends on resistance. So that is nothing but resistance is directly proportional to L. Resistance is inversely proportional to area. So R is directly proportional to length by R is directly proportional to L by A. So here we can take R equal to rho into L by A. R equal to rho into L by A. So R equal to rho into L by A. So rho equal to RA by L. So we are taking from this one rho equal to RA by L. So R is the resistance, rho is the resistivity. R is the resistance, rho is the resistivity. So rho equal to RA by R. See here, if they ask definition of resistivity, so definition of resistivity from formula only we can get resistance of the conductor per unit length and unit cross section area. Resistance of the conductor per unit length and unit cross section area. So that is nothing but resistivity. SI unit of resistivity. So by seeing the unit only you have to identify what is that quantity. So by identifying the unit only we have to identify the, so which quantity they given. Here they given resistivity. So SI unit of resistivity is ohm meter. SI unit of resistance is ohm. SI unit of resistance is ohm. So now I will explain about the difference between resistance and resistivity. Difference between resistance and resistivity I will explain now. Now you can see. So now you can take resistance here one side, resistance I am taking, and here resistivity, this side is resistivity, okay. So resistance and resistivity. So formula if you are taking R equal to rho into L by A. So very important 3 marks question. Very important 3 marks question will come for board exam. So this question is expected even for state. Okay. So state students also you can learn this one, and even ICSE students also you can learn this chapter. So state CBSE state grade 10 and ICSE grade 10 and CBSE grade 10. So this topic is very important. So three boards students. So you can read this, especially this question, the difference between resistance and resistivity. So anyway, it will be helpful for grade 12 students. Grade 12 students, it will be helpful. So those who are writing JE and NEET students also, you can attend the class. So it will be very helpful. The content is very good. So you can note down and you can follow. Okay. So next, so I'm taking rho equal to RA by L. Rho equal to RA by L. So second one, if you are taking second one, resistance depends on length. Resistance depends on length and area. Depending factors depends. Here, so note down as it is how I am writing. So it does not depend on length and area. Does not depend. So length and area does not depend. So even we can also say these are the physical dimensions. Length and area are called physical dimensions. Resistance depends on physical dimensions, but resistivity does not depend on physical dimensions, length and area. Length and area. Okay. So thank you, Tanishka. So third one is so resistance is SI unit of resistance is ohm. SI unit is ohm. SI unit is ohm. So symbol I am taking fourth one. So symbol, this is the symbol, SI unit of symbol. Okay, symbol of ohm. And here we can take a third point, SI unit. SI unit. So they will ask in exam 2 marks, for 2 marks or 1 mark. MCQ's point of view also very important. SI unit of resistivity. SI unit of resistivity is ohm meter. So SI unit of resistivity is ohm meter. And fourth one is ohm meter symbol anyway. Actually words we have to write. These are the symbol. Ohm meter. Ohm meter. So here symbol, this is the symbol. Okay, so next one, that's enough. So this is about resistance and resistivity. And here resistance depends on temperature. Resistance depends on temperature. Okay, resistivity also depends on temperature. Resistivity also depends on temperature. And the sixth one, resistance depends on nature of the material or material. So it depends on material. So whatever the material are taking, copper, silver, iron, gold, like that. So here also it depends on material only. It depends on material. So note down these points. So 6 points. Note down these points. So make a note of it. Make a note of it. Okay. So these are the materials. Depends on temperature here. Depends on temperature. Depend on temperature. Depends on, here also depends on temperature. Depends on temperature. Okay. So make a note of it. See, these 6 points are very, very important. Depend on material also. Depends on material. Depends on. Here also depends on. So very, very important 3 marks question. 3 marks question. Here there are many points are there. 1 mark question may come for exam. 2 marks question may come for exam. 3 marks question. So that much important it is, this concept. So all points are given. So make a note of it. So try to note down. So this is about factored, not difference between resistance and resistivity. This is not about. Yeah. So Shivani, actually It is still it is their area, and see any material if you take any material. So I'm considering any material, length will be there, area will be there. Length will be there, area will be there. Material means surely length and area will be there. If you're taking copper wire, so length will be area. So silver wire, gold wire. So like any wire you can consider. So definitely length will be there, area will be there. But resistivity, it's completely depends on the property of the material. Normally if you are taking copper wire, small copper wire, if you are taking big copper wire also, that particular material nature does not change. Nature does not change, you know. So how much or it opposes, it opposes, but resistance is directly proportional to length. But resistivity depends on the material. Okay, so even it is small or big, if you are taking silver, silver has its own property. So gold has its own property. Iron has its own property. So like that, if you are taking different materials, for particular material the resistivity is different. Clear? Even it is small or big, it is area cross section is more or less. So it depends on property of the material. Okay, so today until 10:30 I'll take class. Those are having lunch, those who had the dinner, you can continue. So if not, just go and have the dinner and come. So join to the class. So now I will explain about resistors are connected in series completed, resistors are connected in parallel completed. Next one, so these are the difference between resistance and resistivity. So resistance and resistivity. So we'll go to the next one. So we'll go to the next point. So okay, so next one, I am going to the heating effect of electric current. Okay, sure, Shivani, definitely can. Carry on, you can carry on. So now I'm considering heating effect of electric current. Heating. So after the class also it will be uploaded as a normal video, so you can watch. Okay, that's fine. Now those are there in the live class, you can continue. So heating effect of electric current. 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 So now you can see. So we know potential difference. Potential difference is equal to W by Q. Potential difference is equal to W by Q. So W equal to V into Q. W equal to V into Q. So what are the work is we are doing? That is nothing but potential difference applied on charge. So then we can take W equal to VQ. So power equal to rate of doing work. Power equal to rate of doing work. Power equal to rate of doing work. So VQ by T. So VQ by T, that is nothing but so V into Q by T. So V into Q by T, that is nothing but P equal to V into I. So P equal to V into I. So in the place of Q by T, so we are taking, so I value, I equal to Q by T, I equal to Q by T. So we can take, so here P equal to VA. So whatever the energy is given to the conductor, whatever the energy is given to the conductor, that will convert into heat. Hi. So whatever the energy is given to the conductor, that will convert into heat. So heat equal to P into T. So P into T, P equal to VI. P equal to VI. VI. So we are considering VI. So like this. So H equal to VI into T. So we know Ohm's law. So V equal to IR. V equal to IR. So I'm substituting here. V equal to IR. Then H equal to IR into I into T. I into T. Then we will get I square RT. So H equal to I square RT. I square RT. So this is very important formula. This is very important formula. This is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. So the formula is H equal to I square RT. H equal to I square RT. H equal to I square RT. So now you can see. So potential difference is equal to work done by charge. Potential difference is equal to work done by charge. So our work done to bring unit positive charge from one point to another point. That is nothing but V equal to W by Q. So W equal to VQ. VQ. Now you are considering rate of doing work is called power. SI unit of power is what? Rate of doing work is called power. So P equal to W by T. So W equal to VQ. Whatever we are considering, that is VQ. I am considering W equal to VQ. So V into Q by T. Q by T is the current. I equal to Q by T. I equal to Q by T I am considering. So P equal to VI. So from this one we are considering whatever the energy is given to the conductor. So that is nothing but P into T. So that will convert into heat. So P into T is nothing but H. So H equal to P, in the place of P we can substitute VI. So in the place of V we can substitute IR. So then we will get H equal to I square RT. H equal to I square RT. This is also known as Joule's law of heating. So heating effect of electric current is also known as Joule's law of heating. Very important. So make a note of it. Practice once. So practice once. Practice once. Practice one time. One time. Practice one time. So how many minutes I'll give? I'll give 3 minutes. So 10:07 I'll start. Practice one time. So this equation and write one time. You can take 10:07 will start. Will start again. PM. Okay, so welcome to the class again. So now I am considering heating effect of electric current completed. Now we'll do some problems, some electricity problems. We'll do it. Some electricity problems. We'll do it. So a few questions are there. So we'll work out on few questions. So what does an electric circuit? What does an electric circuit mean? The continuous and closed path of an electric current is called an electric circuit. And the next point is name the SI unit of electric charge. Name the SI unit of electric charge. SI unit of electric charge is coulomb. So how much is the charge of an electron? So can a charge less than this value exist? No, charge of an electron is 1.6 into 10 power minus 19 coulomb. So charge of an electron. So charge of an electron is 1.6 into 10 power minus 19 coulomb. So less than this value does not exist. And the next one, how many electrons constitute in 1 coulomb of charge? How many electrons are constitute in 1 coulomb of charge? In 1 coulomb of charge, so 6.25 into 10 power 18. 6.25 into 10 power 18 electrons. 6.25 into 10 power 18 electrons. In 1 coulomb, this many electrons are present. This many electrons are present. So define electric current and SI unit of electric current. Define electric current. The rate of flow of charge. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. SI unit of electric current is ampere. SI unit of electric current is ampere. And the next one, define SI unit of electrical potential. So here potential difference is different, electrical potential is different. Define SI unit of potential difference we'll discuss. Next one, electrical potential. Potential difference is nothing but the work done to bring unit positive charge from one point to another point within the conductor. So if I am taking this one, so we are taking here this the point A and this the point B. So we are doing some work. So we are doing some work to bring the positive charge from point A to point B. So that is nothing but electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. Infinity to the required field is electrical potential. Work done to bring unit positive charge from one point to another point within the conductor. Within the conductor is potential difference. So from infinity to the required field is electrical potential. State the relationship between 1 volt and 1 joule. 1 volt and 1 joule. So the relation between 1 volt and 1 joule is, so the relation between 1 volt and 1 joule. So here I will tell, just see. Relation between 1 volt and 1 joule is, so 1 volt equal to, so normal the formula is V equal to W by Q. V equal to W by Q. From this, so 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. So 1 volt is defined as, what is your name, sir? What is your name, sir? What is your name? So my name is Shiva, sir. So I'll teach physics. So now it is going on CBSE grade 10 physics. Any other doubts? So if you are new to the channel, please do like, share and subscribe. Okay. So I will explain the next question. Name the device used to measure electrical potential difference and state how it is connected in an electric circuit. So name the device used to measure the electrical potential. Electrical potential is voltmeter. So voltmeter is used to measure the electrical potential. So how we are connecting? How we are connecting in parallel combination. So what is meant by resistance of a conductor? So this point is very important. Resistance of the conductor. So resistance of the conductor is nothing but the phenomena of opposing the electric current in the circuit. The phenomena of opposing the electric current in the circuit is called. So the phenomena of opposing the electric current is called resistance. SI unit of resistance is ohm. SI unit of resistance is ohm. And here you can see define the define resistivity of a material, give its SI unit. Define the resistivity of define resistivity of a material, give its SI unit. Define resistivity of material, give its SI unit. As I said you can see here I am considering. So R equal to rho by L by A. So rho equal to RA by L. Rho equal to RA by L. R equal to rho into L by A. Rho equal to RA by L. So resistivity is equal to resistance of the conductor. So here I am considering R by L into A. R by L into A. R by L into A. So resistance of the conductor per unit length and unit cross section area. So that is nothing but resistivity. SI unit of resistivity is so ohm meter square by meter. Then we'll get ohm meter. So this will get cancelled. Then we'll get ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Clear? So this is about SI unit of resistivity. Next one. So we can see state Ohm's law and write the condition in which this law obeyed. Ohm's law we have to discuss. What is Ohm's law? The potential difference across a metallic conductor is directly proportional to current flowing through it. The potential difference across a metallic conductor is directly proportional to current flowing through it. So V is directly proportional to V equal to IR. So Ohm's law gives the definition of resistance. And conditions means so at a constant temperature, the potential difference is directly proportional to current flowing through it. At a constant temperature, the potential difference is directly proportional to current flowing through it. So that is nothing but Ohm's law. Okay, and physical conditions also constant. So not only temperature, physical conditions also constant. So here list the factors on which resistance of the conductor depends. List the factors on which resistance of the conductor depends and write the formula. So formula here. So I am considering now. So here you can take resistance is directly proportional to length. Resistance is inversely proportional to area. So R equal to rho into L by A. So this is the formula. So the question is, so list the factors on which resistance of a conductor depends. Write the formula showing the relation of resistance with these factors. So this is one of the board exam question. So they ask in the board exam this question. Next one. So simple question. I'll ask one question. How do you connect an ammeter and voltmeter in an electric circuit? Ammeter will be connected in series combination. Voltmeter will be connected in parallel combination. Distinguish between terms related to electrical resistance and resistivity already explained, so that question. Next one, these are the problems are there, so it will take time to do the problems. So now we were working on theory questions. Once theory questions completed, then we'll go for problems. So sometimes we have to draw the circuit diagram also. Circuit diagrams also they will ask by giving the ammeter, voltmeter, resistor, rheostat. After giving all those things, so they will ask about draw the diagrams. So we will draw. We should draw. What is the resistance of an ideal ammeter, ideal voltmeter? Resistance of an ideal voltmeter is infinity. Resistance of an ideal voltmeter is infinity. So what is the resistance of an ideal ammeter? Resistance of an ideal ammeter is 0. Resistance of an ideal ammeter is 0. Resistance of an ideal voltmeter is infinity. So this is about today class. So if you like this video, please do like, share and subscribe to Student the Brand. So as I'm saying, I started the course CBSE Grade-10 Physics, Light Reflection and Diffraction, Human and Color Fluid, Electricity, Magnetic Effects of Electric Current. So these 4 chapters explanation and notes I'm providing, notes along with the notes and 100 definitions from these 4 chapters, 100 problems, 100 problems from electricity chapter. So this all I'm providing soft copy. So and explanation of these 4 chapters. So if the cost of 500 rupees, I'm providing this course. So those who like that content, so you can contact to this number 9849812804. So 98498984981280. So you can contact to this number. So this is your Shiva sir. So if you like this content, please do like, share and subscribe to Student the Brand. So namaste. Thank you.